One more step just to make our lives a little bit more complicated is we're going to now figure out how we can count atoms in moles of molecules. So for example, we'll be able to answer the question, how many atoms are in 2.4 moles of water? You should already know how to count atoms from chemical formulas. So let's do a little super quick review. Remember that our subscripts will tell us how many of each atom we're going to have. In this case, sodium has no subscript, so that's just going to be one sodium atom. And chloride also has no subscript, that would just be one chloride atom or ion. And then if we did the rest, we would do the same thing. So for potassium, you have a little subscript 3 after it. That would be 3 potassium atoms. Our phosphate has no subscript, so that would be 1 phosphate atom. And our oxygen has a subscript of 4, which would be 4 oxygen atoms. So if we were going to answer these questions, we could do the same thing for all of them. If we want to answer these questions, we can just count out the total number of atoms and say there are 2 atoms total in sodium chloride, there are 8 atoms total in potassium phosphate, there are 8 atoms total in sodium acetate, and there are 3 atoms total in water. I would encourage you to pause this video and just make sure that you're comfortable with all of that. All right, next thing is you also already know how to write equalities from sentences. So from the sentence, there are 2 atoms in each sodium chloride molecule. You can write the equality 2 atoms equals 1 sodium chloride molecule. So you could go through and do that for all of these. Again, I encourage you to pause the video, make sure you're totally confident in this and going from a sentence to an equality. And finally, you also know how to write conversion factors from equalities. So given the equality 2 atoms equals 1 sodium chloride molecule, we now have a conversion factor that can take us from units of atoms to units of molecules, or from units of molecules to units of atoms, or from units of atoms to units of molecules, by taking one side of the equality, 2 atoms, and putting it on top of the other side of the equality, over 1 sodium chloride molecule. And then we can do the flip side of that as well. As a quick reminder, the reason that this works is because we are using the math fact that anything divided by itself is equal to 1. 2 atoms, we're saying based on this equality that 2 atoms is the same as 1 sodium chloride molecule, right? So in this case, our A is the same, top and bottom, they're just written in different ways. And then if we did the same thing, our 3 atoms equals 1 water molecule. Notice that I've written the chemical formula here, H2O. We could write the conversion factors 3 atoms divided by 1 H2O molecule equals 1. And 1 H2O molecule divided by 3 atoms also equals 1. First step for solving this problem then, how many atoms are in 2.4 moles of water, is to identify what we are given and what the problem wants us to find. I go through this in a slower way in some of the other videos, so I'm going to go a little bit faster this time, hoping that you've gotten a little bit more familiar with this. If you're struggling with this, you have a couple options. Go back and rewatch some of the previous videos, or talk to me or Ms. Sproul and get your questions answered. So in this case, we are given 2.4 moles of water, and we want to go to the units of atoms. How many atoms? So I drew this little slash through moles of water to remind myself I'm trying to get rid of the units moles of water. The next thing to do is write down anything you think is going to help you. This is a super powerful problem-solving technique. In this case, we're always going to be thinking of equalities, right? But really, for any problem that you encounter in this class or any other, this is a great technique. Write down anything you think might help. Half the time, you're going to write down stuff that you don't need. That's fine. Still write them all down. You don't have to use them. But that way, you see all your tools right there in front of you. In this case, the 2 equalities that I'm interested in are ones that are going to relate moles to something else, and one that's going to relate to number of atoms. In this case, notice that there is no equality that takes me straight from moles of a molecule, because water is a molecule, to atoms. I want you to think about why that is. Until now, we have been talking about talking about how many molecules are in 2.4 moles of a molecule. But if we answered this question, for example, if I said, how many, let's look at this equality, 6.022 times 10 to the 23rd molecules equals 1 mole of molecules. So we were doing this for water molecules. Here's one water molecule. I'm going to do my hydrogens in blue. Here's one water molecule. And if I had a mole of these water molecules, I would have 6.022 times 10 to the 23rd of them. That's not the same number of atoms I would have, though, right? Because for each of these molecules, I actually have 3 atoms. I have 3 atoms. So if you think about it, I should have 3 times as many moles of atoms as I do moles of molecules. That's just one thing that hopefully that makes sense. There's one molecule here, but there are 3 atoms here. So if I have 6.022 times 10 to the 23rd moles of these, that does not mean I only have 6.022 times 10 to the 23rd atoms, right? I'll have 3 times as many. And then the other conversion factor that I have here is, the other equality that I have is 3 atoms of H2O is going to equal 1 molecule of H2O, right? That's something we just did in the previous slides. And once again, from these, I'm going to write my conversion factors. You want to write them out so you can use your tools. At some point, you'll get good enough at this that you don't have to write it all out, but for now, write it all out. So here's our conversion factors. Now we're ready. That was the whole setup of our problem. Now we're ready to solve it. So I want to write what I'm given as a fraction. I'm given 2.4 moles of water. Again, I'm going to write it with my chemical formula, 2.4 moles H2O. And I'm going to put that over the number 1. That turns it into a fraction. Next, I want to select conversion factors to cancel out units until I have the units that I want. In this case, I'm trying to cancel out moles of H2O. As you can see, I have to choose the conversion factor that has moles in the bottom. This is a general way to write that, right? 6.022 times 10 to the 23rd molecules of something is going to equal 1 molecule of that same thing. So here, just to make it nice and clean, I went ahead and plugged in what kind of molecules I'm talking about. So 2.4 moles of H2O, and I'm going to multiply that by 6.022 times 10 to the 23rd molecules of H2O, because that's what I'm talking about, divided by 1 mole of H2O. And that lets me cancel out my units of moles. The next conversion factor I need will help me get rid of molecules because I'm not looking for molecules of H2O. I'm looking for how many atoms total. So I need the conversion factor that lets me get rid of molecules of H2O. Between the two of these, the one with molecules H2O on the bottom is this one. So if I plug that in here, 3 atoms H2O divided by 1 molecule H2O, once again, I get to cancel my units and check out my units that I'm left with. Atoms in H2O. Right? This is a very confusing way to write that. I apologize. It would have been better for it to just say atoms, but I can't be perfect. Can't be perfect, so we'll just have to deal with that. And so if we calculate that out, let me move my face again. We're gonna multiply across the top of the fractions to get 4.34 times 10 to the 24th atoms in H2O. Again, it's probably should have just left the H2O there because H2O is not an atom. It's made of 3 atoms, whatever. And on the bottom, I have 1 times 1 times 1. Notice, I only include the units that I didn't cancel out, right? This made it super simple in my final answer because the only units I have are the ones that I want. And I can use my simple math rule of anything divided by 1 is equal to itself. To simplify this just even the littlest bit further and not write it as a fraction. So my final answer is, to the question, how many atoms are in 2.4 moles of water? My answer is 4.34 times 10 to the 24th atoms in that amount of H2O. And again, I'm just going to it's bothering me. This little H2O should not be here. Okay, just pretend it's not there. It looks like a ghost. Just pretend it's not even a ghost. It's gone.